Today's notes are on 2.2, graphing quadratic functions in vertex form. This is going to be a two-part or two-day section because we're also going to be graphing standard and intercept form the next day. But for today, we know that there are vertex form, standard form, and intercept form, the three forms of quadratic functions, and each form allows you to easily find a different critical point. Now, critical points are vertex, y-intercept, and x-intercept. So for today, all we know right now is that vertex form that we've been graphing is a parentheses x minus h with the squared outside plus k. And the vertex from this function is h and k. Okay, and hopefully you remember that we're going to take h, but always switch signs of the number inside the parentheses. Okay, the y-intercept is always a y value on the y-axis, right? So on the y-axis, the x value is always 0 because I don't move from left to right. And then you go up and down. Oh, let me change that autofocus. Sorry about that, guys. And then you should be going up and down by a certain amount. Now, how do we do this? You plug in x equals 0 and evaluate. Evaluate means that we're going to do what we see. So whatever operation you see, that's what we do. So if you see like 5 times 2, great, then that's what we're going to do. Solve means we do the opposite, right? So if you do like x times 2, then we do the opposite, which is divide by 2. The x-intercepts are going to be a number, comma 0, right? So the y-intercept is when x equals 0, and the x-intercepts are when y equals 0. Now, so far, we don't know how to solve. We're going to solve in chapter 3. But for right now, we're going to use a pattern. And the pattern we're going to use is the 1, 3, 5, 7 pattern, okay, for quadratics. So far, we've been just doing the vertex and then the first slope, and then we draw a U-shape from there. Let's talk about the rest of the graph now, okay, because these are sort of important. So on the side, you don't need to write this part down, but the parent function for quadratic functions is y equals x squared, right? So if I'm doing just like plugging in x's to see what's going to happen, I could start at 0, and 0 squared is 0, 1 squared is 1, 2 squared is 2 times 2 is 4, 3 squared is 9, 4 squared is 4 times 4 is 16, 5 squared is 25. And these are the perfect squares. Hopefully they look really familiar to you. Well, if I'm starting at 0, I will go from 0 to 1 by adding 1. I'm going to add 3 here. From 4 to 9 is adding 5. From 9 to 16 is 7, and 16 to 25 is adding 9. And you can see, so for quadratics, this term right here, or this change, is increasing by 2 every time. So that's the pattern we're going to use, because this is my parent function, x squared, right? So that's my 1, 3, 5, 7 pattern. So let's do a quick fill-in real quick. We're going to identify the vertex, h and k, and plot it right away. Remember to change the signs for the number inside the parentheses, which is your h. Okay. These two will fill in tomorrow. Now we're going to find the axis of symmetry. Now the axis of symmetry is a dotted line that if you have a parabola, it's this dotted line down the middle. Okay. It's invisible, that's why it's dotted. It's not a solid line, so they're never going to touch or cross. But what this is that it helps you decide that the right side is exactly the same as the left side. And it's always going to be in the middle, right here, which is your h value of your vertex. Let me show you what I mean. So if you come over here, the vertex is the opposite sign of -1, so it's +1, -4. I'm going to graph that right away. +1, -4. Okay. And the axis of symmetry is this dotted line That means this is the exact middle on the vertex, so you don't mess up. I extend the line a little bit above and below to make it clear, right? Because if you're using pencil, it's not super clear. So this axis of symmetry line is where x equals 1. That 1 comes from right there. Okay. Here's my vertex. Now from here, I can use my pattern, which is 1, 3, 5, 7. And I can go up 1 over 1, up 3 over 1, up 5 over 1, and 7 doesn't fit. I'm going to expect you guys to extend it all the way to the edge of the graph. So if 7 fit, then you would need to put 7 on here. Then I'm going to go up and to the left, up 3 and to the left, up 5 and to the left, using these as my slope patterns essentially. Okay. Now once you do that, you can find the y-intercept from the graph, which is right here. Oops, sorry, that's my x-intercept. Where's my y-intercept? My y-intercept is here. I apologize. Okay. This is my vertex. And these two are my x-intercepts. So my y-intercept is down 3, so that's 0, -3. Notice the number is where the y is. My x-intercept is -1, 0. Don't put the two numbers together. This is a separate point, and this is 3, 0. What do we do if the y-intercept is so big you can't see it on the graph, though? Okay, so let me connect this with my fairly beautiful parabola. Well, if the y-intercept is too big, you can also solve for it by, take a look, plug in x equals 0. So let's write that in. Okay. We did say the pattern is 1, 3, 5, 7. Okay. We'll fill this in a moment. So if I'm going to plug in x equals 0, that's the same as saying f of 0 equals, and I'll plug in 0 minus 1 squared minus 4. That's -1 squared minus 4. -1 squared I want to be really careful of. If you type it into the calculator without parentheses, it's not going to go well. Because what it really is -1 times -1, which is +1 minus 4 equals -3. You guys see how that matches what you see here. Okay. So the domain is sort of a gimme or a freebie. The domain means all x values and range is y values. So for domain, any x value can be plugged into this function. So we have all real numbers. Okay, so I'll write this out. This is all real numbers. This symbol with the two lines and then an R is not IR. Okay, so I'm going to write it slowly on the side here. I'm going to do first line down, second line down, and then just draw your R as if the second line wasn't there. Okay. Range is y values. Now this one's not all real numbers. Which y values are used in this red parabola? Well, if you look here, this is my lowest y value. That means my smallest, right? And so my smallest y value is at this point right here, which is the -4. So do you guys see the axis of symmetry uses the vertex x value and the range uses the vertex y value? And then the question is, are we going to say y is greater than -4 or is y less than -4? Okay, well, we know that we are going up in our parabola. You guys see that? We're going up from -4. So that means it must be greater. So then the question is, which one is which? If you put your hands like this, the left hand is your less than symbol. You see how L for left and L for less than. Well, we want greater, so it's this one. Okay. And -4 is filled in, it's a point, so we have y is greater than or equal to -4 for this parabola. I'll do a second example. Okay, so if you wanted to try, fill in your vertex. Ooh, this is a mistake on my worksheet. Please fix it. Okay, so my vertex is -3 turns into a positive 3, and that 8 I fixed. And the reason why it had to be positive 8 is because it's going to open down according to this negative slope. Okay, axis of symmetry is always the same number right here. So I'm going to go 3, 8. 10 is all the way to the top, so I just counted down 2. I'll draw my axis of symmetry right away, so I know where I'm counting from. And then I'm going to go down 2 over 1 and down 2 over 1, which we know is our slope here. The problem that we're having right now is that it no longer follows our pattern of 1, 3, 5, 7. So our pattern for the parent function is 1, 3, 5, 7. But if we have a negative 2 in front, we need to multiply by a equals negative 2. Okay? So I'm going to times negative 2 times negative 2 times negative 2 times negative 2. 1 times negative 2 is negative 2. And then I have 3 times negative 2, negative 6. And then 5 times negative 2, negative 10, and negative 14. Well, now I'm ready to draw or plot the rest of my points. Okay, so from here, remember that you're going to use the pattern and multiply it by a. We did not need to multiply here because our slope was just 1, or a is 1, right? So I'm going to go down 2 over 2, down 6 over 1, sorry, down 2 over 1, down 6 over 1. These are all over 1s. Okay? And then down 10 over 1. And our x-intercept and y-intercept comes out when we do the pattern on the other side. Okay. So our y-intercept is right here, which is negative 10. Our x-intercepts are at 1 and 5. Our domain is always all real numbers. And our range is going to be less than 8. Right? It's less than. So it's going to be y is all values less than or equal to 8. Okay? So I do strongly suggest at this point, please pause your video, turn your paper over, and try the U-tries on the back. We will be doing this for our warm-up, so on Friday. So if you're doing this after Friday, do it yourself. If you haven't come into class yet for Friday, just we'll try it together. I'm going to pause and then I'll show you the answer key in just a moment. Hi, so I'm just going to give you the first two so you can take a look and see. This one was very straightforward. We have our vertex at 3, negative 9, and the pattern is exactly the same. This one was a little bit weird. We started at negative 3, 3, and when we used our pattern and multiplied it by negative 3, we get negative 3, negative 9, and then negative 15 obviously doesn't fit. The problem being that our y-intercept is down furthermore. Now you could take 9, add 15 to it, and get a y-intercept of negative 24, or you might need to plug in 0. And so if I plugged in 0 right here to this original function, 0 plus 3 is 3. And instead of writing 3 squared, where a lot of students tell me 3 squared is 6, I did 3 times 3 times 3, which is 27 plus 3, negative, right? And then negative 24. So once you have that, then you know your y-intercept is negative 24, but it doesn't fit on the graph. I'm not going to show the other two, but if you've got it, I think you're ready to try your homework.